Here's a lovely old Selmer TruVoice amplifier made about 1950. Now I've done one of these before, fully serviced it and everything, and worked out what needs to be changed to get it to work. But I'm going to go over again some of the features about these lovely old amps. Now this is the one that I've just come in to be fixed, and this is the one that I own myself, and you can see they look very, very similar, if not the same. Now I've got an original advert here for the Selmer, the TruVoice 15 amplifier. It says 5 valves, tone volume controls, high and low input impedance, 12-inch move-in magnet coil speaker, 30 to 10k, built into plywood foundation, waterproof leatherette covered case, and the size and the weight. Also, there's another ad here and speaks of some of these others. TV6, 12, 18 and 20 with tremolo. They were very expensive, 47 guineas in about 1950, a lot of money. It also talks about better safe than sorry, and talks about an isolating transformer. Not totally true, because it's only on the low input impedance input, which I'm going to show you on these amps. And if you get one of these, as I explained in the previous video about it, you have to be very careful if you don't want to electrocute yourself, because the high input impedance, where you plug your guitar in normally, is connected directly to the mains, and you can electrocute or even kill yourself if you're not careful when you use one of these. They look exactly the same. This one has got the original handle, leatherette. It's got been sort of stapled to the top. This one has had the handle changed. Very old handle, but you can see the original holes where the original handle went. It's got the original Bakelite knobs. They still look the same on the fronts. Still the plastic, and the grill cloth has just about survived on both of them, which is excellent. So let's turn them around and look at the back. So looking in the back, now this one didn't come with a cover over the valves. This should be a safety cover, and I've unscrewed it across the valves like this one had. It's screwed on the back, and it covers the valves over, and this, which is, these terminals are live connected to the mains, as is this fuse, and anyone putting their hand in could electrocute themselves. Also, the valves get very hot. Again, anyone touching them wouldn't be a good idea. But as you can see, same layout, looks very similar. Considering I looked at the serial numbers, and this one is a 100688 and this is a 100814. So not very far apart on serial numbers, but there's some noticeable differences. And in those days, they used to buy the components wherever they could to make these things up. And so you do get differences. This Barretter, which is a resistor that drops the mains all the way down. Now there's no isolating transformer in this input transformer. The mains comes directly into the circuit. It doesn't go through a mains transformer, so you won't see a big transformer you see in modern amps anywhere inside. And they're both original. I can see they've never been changed. And also, as I said, the drop-in resistors are still got the same number of connections, but a totally different design. This one's got the lovely RS logo on it, and it says 800 ohms, 3 in England. RS used to be the source of many components in those days, including when the very first Marshall amps were made using RS components. RS transformers. A lot of components came from RS in those days. Stands for Radio Spares, a company that's still going. As you can see, it says 200 or 240 volts There's an on-off switch, exactly the same, and there's input. This is high impedance, low impedance. The valve complement's the same. There's a capacitor out the back. But another thing we can look at is the speakers. Well, they're both Goodman's Audium speakers, but this is an Audium 50, 10 watts, 15 ohms, and this one's a 15 watts Audium 60. So for some reason, this definitely looks like the original speakers in both, but this one it's got a better speaker than this one. Cones, nice and tight. There's nothing wrong with the speakers at all. So again, shows you that there's a variation. There should also be a back cover on these, like a plywood thing. I think it clips on there, but they're missing. It's a shame this one's lost its metal cover. So the best thing you could do for safety would be to make a little wooden, a grill or something, unless you just want to look at it, but you couldn't take it somewhere where a public or some kid or anything could put their hand in. It'd be very, very dangerous. Now I'm going to show you another thing about these before we look inside, and that is the safety or isolation. And normally you'd use a high input impedance input these days for guitars, etc., and that is this one here. You plug the guitar in there. You think you'd be fine. Well, let's have a look what happens. Here's the mains plug. Let's connect to the earth where you plug your guitar in, which would be all the strings and everything on your guitar. And here's the mains plug, live, earth and neutral. Look at that. Connected to the neutral. It's a dead short to the neutral on the mains plug. Now if someone wired this plug up back to front, which you could do, or even the socket in the wall, wherever you're plugging it into a hall or anyone, old house, the wiring could be back to front and you could be connected directly to the live. And then if you then decided to lean against a radiator or something, which would be earth, you would then be connected directly to the live, and you would either get a massive shock or possibly even kill you. So incredibly dangerous if you buy one of these old amps. Now this other input is a low input impedance, and that's fine, but it's no good for plugging a guitar into. But these days with modern buffers and that, you could possibly use it because it's not connected to the mains at all. Let's just see if you can still see. It's not connected to either the plus or minus or even the earth, because it goes through a transformer, and it's this transformer they speak of here. But it is a transformer. It will rob you some of your sound, and you will, it's a low input impedance, you will have to use a buffer between your guitar, but it is isolated. How can you get around it? Well, I recommend using an isolating transformer, which is what I would use. This is a quite powerful one because I use it on other equipment, 100 watts. With this one you'd need, I would recommend at least a 50 watts because these things do get quite hot. Now this is a complete isolating. The input goes, it's like a transformer that all amps have, like a mains transformer, but built into this little case. It's not connected between the input and output. There's no physical connection on the wires, so it's totally isolated. So you plug that in and you plug the amp into a socket, that is, and you plug this into the mains, and it's safe. You'll never electrocute yourself. Then you can, I put an earth link on here, which you can if you want, because someone took this amp and thought they knew what they were doing. They decided to change the mains wire. I'll show you. Let's have a look inside carefully. They've added a new mains wire here. You can see the earth wire, and they've bonded it or screwed it to the side to the chassis. But on these things, the chassis is not actually connected to anything at all. Okay, it could give you a little bit of screening from electrical interference, but it is not connected to anything, the chassis. And here we can see this buzz bar, well, everything's connected to, looks like a normal earth buzz bar that you find in all lots of amps. But that isn't connected to, it's not connected to the earth at all. It's not connected to the earth, but it is connected to the main, it's connected to the mains. See that on the meter? So I think they thought that this was an earth wire, and by connecting an earth wire from the main to the chassis, it would all be safe. But in fact, it made absolutely no difference whatsoever, because the chassis is not connected to anything, and this is connected to the mains. The transformer down here is your input transformer, the one that they spoke of in this ad, and that's connected to the low input impedance, and your guitar high input impedance is connected directly to this buzz bar connected to the mains. That is rather a long explanation, but you need to know what you're doing if you get one of these old amps and think you're making them safe. Now, as I say, this one I completely serviced. I had to change a number of parts. From the 50s, you'd expect some of the parts to have worn out. The valves, I tested them all, and they were all fantastically perfect. Valves made in those days by Mallard and people were so well made. Absolutely, I put them on the test, they're all great. This can burn out. It's a wire, lots of coils, and it gets very hot, and they can burn out, and these contacts are just bolted on, and they can corrode and lose contacts. But that was flopping around. Luckily it's screwed down. We screwed it down. It's got a bolt through the middle that squeezed it together, and it was fine. And the transformer was fine, the speaker was fine, but a number of things inside needed changing, and weirdly the interstage transformer needed changing. Interstage transformer it's got, which is used as a phase splitter to drive the output valves, and I think it's one of the things that gives this amp such a superb sound. This transformer's gone, don't know why, in this one, and I managed to get a Hammond interstage transformer, screw it in, rewire it, and it worked perfectly. The bulb still worked. I don't know if it's a 50-year-old bulb, but still did. Now, looking at this one and the other one, there's a couple other differences. This transformer's quite shiny, but I think it's definitely original. This one's a bit more green and very slightly bigger. This is the actual speaker output transformer. The one on top is actually a choke, a giant choke, which transformers were cheaper in those days than other components. These days transformers are more expensive than components like capacitors. In those days were very expensive. So they used a choke for smoothing the mains, which you don't see too often because chokes are expensive, big chokes, and they're quite heavy too. And the ones on top, you can't see them in the back, are the chokes. These are the speaker transformers. And just looking at a few other differences, you can see the layout, these old things. I've changed that electrolytic there, which obviously was a problem. and I've changed the big smoothing one as well on here, which obviously was a problem when I checked it out. These wax dipped ones I found were all fine, and the resistors are just about all fine. There's slight variations in the components used, a little wire round there and a different sort of one. As I said, they buy the components wherever they could in those days, as long as they're about the right value. These things get hot, they're spent in mid-air. The switches survived, they're not broken. What else? And most of these old components are fine. As you can see, it's all pretty much handmade. You can see that someone sat down and bent and soldered all these components into place with this bent piece of wire. There's a bit of screen cable there. That goes up to the top cap on the valve. The grid input on these old valves is actually on the top cap. So the very first stage, they screened it off to try and prevent any pickup noise or interference. I haven't turned this on yet. I don't know how many things are going to be wrong with it. I'm going to have to be careful in case anything is especially the capacitors. If any of these capacitors are leaking high voltage. Transformer has a tap. It's a 16 ohm speaker. It's got an 8 ohm tap. Well, that's the differences. I've done this one, and luckily I drew out a complete circuit. So now I know exactly what I'm looking for. I even worked out the Barretter, how it drops all the voltages to the heaters. These old valves using 26 volt heaters, 25 volts, and two were 6.3 volts, and they're all in series off the mains to drop the voltage all the way down from 240 down to 0. It's got the bulb there as well. Rectifier, big choke, capacitor 16 microfarad, 8 microfarads. Pretty, when you look at these circuits, it's fairly conventional. Comes in, it's like a pentode. The top cap on the grid, I'll show you that in a minute. Very conventional tone control, just knocking off the treble, and the volume control, just controlling it into the next stage. So you bypassed cathode, all very normal, 100k load, 37k load there, and quite a low resistances on 820 ohms, 680 ohms. Then you got that interstage transformer, which is used as a phase splitter and drives the two output tubes, which are beam pentodes, they're called, KT33s, lovely old valves, driving into the speaker transformer fairly conventionally. A couple of high frequency capacitors. So the circuit's pretty straightforward, except they're using an interstage transformer as a phase splitter. Valves, connections, data I got off of their spec sheets. The layout, there's choke, big capacitor, and the mains came in here through a fuse. There's that buzz bar I speak of, and the chassis had 0.1500 volt capacitor just to isolate the chassis from any noise pickup. As I said, in this one, someone's put an earth to the chassis, so the earth would come in off that 3-pin plug and screw to the chassis. If something got bent or fell off and shorted to the chassis, at least it would blow a fuse. I'll just show you that valve here. These are KT63s. Let's be careful with these. that is not a high voltage connection. Some valves you'll see with high voltage connections on the top, these are not. This is actually the grid input signal input on the top, and this one, that is a screened cap to keep any noise off. The very first stage, keeping any noise pickup off. The valve bases are this one's on a rubber mount as well to stop vibrations affecting it. So I thought quite a lot. They're trying to make quite a nice musical amplifier and trying their best. That is the choke, as I said, not that's the choke in there, not the output transformer. This ballast resistor, you see it's got these clamps, so it's pretty easy to check whether they're done up tight and haven't come loose over the years. You can, all these connections, make sure they're tight. Ballast resistor, or barista, or they call it actually a Barretter, you'll find this thing is called. If this was not working, burnt out, it would be very difficult to find a replacement, if not impossible. The capacitor, it's I changed this one on the other end. I'm going to have to check how good that is. It's got a little insulation on it, and there's the lovely big choke, just 2 wires in and out. You can see the bit of rust on this. It must be the original. It looks like it's been resoldered at some time, but if it's not an original speaker, it's very, very old anyway. I decided this valve's got to come out, so I can turn this upside down and work on the inside. So holding that tight so it can't move around, I used the spring very carefully and it came off. This has got some screening on it too, up to there. The other one's got a complete screen top cap with the connection inside. So now I can take this out, right, which is good. A lot of amps, even modern amps, have very weak pressure contact on the pins, which is very poor. These are really nice bases, very nice design. This capacitor here, one of the smoothing capacitors, it's important that that works quite well, otherwise you're going to get some noise, a hum that's left over. And it's this one down here, it's a Hunt's, which was never great, and it's working at fairly high voltage, so I've disconnected the end to get a read in. It says it's 2.6, which is not great, but 13, which is quite a lot higher than it was originally, means it's probably drying out. It's a fairly easy thing to replace. It's on a clamp, so I'm pretty sure I'm going to change that one. I've checked these down there. They're okay. They're working at fairly low voltage. I've checked various resistors. I'm not going to change these ones which have high voltage on them. That one and this one, until I turn it on, see if they've got any leakage, because I just don't want to change them just for the sake of it. This is a 0.1. That's a 0.02. I can actually read it on the side. On an earlier circuit I've got of a model T2U, that's only a 0.005 in there. One on down here, 12, it says it should be 126 ohms. That one there actually measures, I just measured it, 126 ohms. The one on the other amp was 250 ohms, so I'm going to measure the milliamps flowing through these when I get it up and running. Don't like the way these two capacitors have been installed. This is earth on this end, and this one's is to the cathode, and they're so close together that I'm sure, and this one's not even held very well, they could eventually touch if it was vibrating, which is not good. This one's on a clamp, and that one's not on a clamp, and even this one slides about quite easily. So I'm just going to put a bit of something in there just to stop them touching. Testing the ESR and capacitance of the big smoothing capacitor. It's supposed to be 1616. One side is. That side, you have to have taken the connection off to get an accurate reading. On the other side though, it's 28 and 1.32 ohms. So as they dry out, the capacitance tends to go up as the plates get a bit closer together, but the voltage breakdown can get less and less because of that. So I always check the mains plugs on anything that's servicing, just to make sure the wires are done up all correctly and not coming out. And also I don't like using 13 amp fuses for these sort of equipment. A 3 amp is easily good enough. So I've connected up below the voltage monitors to the circuit, and I've slowly ramped up the voltage on the Variac through the isolating transformer, drawing just below about 400 milliamps. I assume that's mainly due to the heaters, 236 volts. The voltage is a bit low. I've got this one 170 volts, and is the first stage off the rectifier. On my other one it was 220, dropped to 207, then 171. This is 170 dropped to 155 and 130, so the voltages are way down. Also monitoring the voltage on the cathodes of the push-pull. On the other one it was 16 volts. On this one it's only 9 volts. It's not right, the voltage isn't right, which either means that the rectifier is not doing its job. Controls up the top here, I'll just turn the volume, it is working. Very noisy, I can clean that, so it's not like it wasn't working. So I was wondering why the voltage 174 volts off of the rectifier is so low. It should be near the mains voltage because it's rectifying the mains, and I measured 220 on the other one I repaired. Only 170 point something, that's with 235 volts in. The current is quite high, 0.4, and that's the voltage is dropped all the way through the chain of heaters, a resistor on the Barretter. So I was wondering about it. So there's a switch on here, 220. I thought, is the rectifier not working properly? And so I turned the voltage down to say 210 volts, and then you see it drops a lot, and then we can switch out this resistor with this switch here to the 220 setting, and it jumps to the correct voltage. So the rectifier is obviously working. So that's weird. Put it back. And I noticed the bulb wasn't working either, so I thought the bulb was blown. The bulb's not blown, the connections on the bulb are fine. And then these two white wires here go to the bulb, are wired off the Barretter here and here, and I discovered that they're the wrong way round. And in fact, by whoever put this together, it must have been done at manufacture. This one has a brown wire goes off to the rectifier, and this one is just off the Barretter. If you wire them the wrong way round, it shorts this 40 ohm out, and it goes round there straight down, so the bulb's not working. And what does that mean? Well, it means the heaters work at higher voltages, they draw more current. More current flowing down means that there's a big voltage drop across this part of the Barretter here, which is feeding the valve. So the valve gets less voltage, and so the output is less. And it's in fact, whoever put this together, I mean, why have two white wires? How confusing can that be? And you'd think that, oh, it's just a bulb, you can wire it one way or the other, but it's got a brown wire off of this white wire as well, and these have just been put on the wrong way round. So I'm going to unsolder them and swap them over, and we should see the bulb come on and the voltage go up. I mean, that bulb couldn't have been on from the day it was manufactured, and because it shines through this little, maybe no one noticed or thought the bulb just wasn't working, couldn't be bothered to change it. Very strange. So it's never worked properly since the day it was made. I've changed the wires over, start ramping up the voltage, and yeah, the bulbs are light. And just turn the voltage up. It's on the 230 to 240 volt setting, make sure that's right. Turn it up to 235, bulb's getting brighter. 235, bulb's really bright now, and just watching the voltage come up. The voltage is going to be... I've taken the control panel off, it's held on by 4 little screws. And this wood needs gluing back on, that it's fixed to, just about to fall off. And the capacitor, I better check that affects the tone, cuts the treble, doesn't seem to be doing anything at the moment. I'm getting somewhere with this amp after fiddling around with it. I've just got a guitar plugged in the high Z input. The volume, it's on its side. I've had to clean these pots the best I can. They were really scratchy. The tone control doesn't really do much at all. The volume is a bit iffy. It cuts out a bit halfway up, and then comes back on again. Let's have a look at that potentiometer. I'm getting somewhere with this. One thing I have to assume when repairing old equipment, especially very old, or any equipment really, is that when they made it in manufacturing, it left the factory, it was actually been tested and had been correctly made, and it was all working fine. So therefore it can obviously be returned to that sort of condition if there are any failed components, and get it working okay. And so when I'm trying to fault find, I'm assuming that, and I'm not really looking for manufacturing faults. With this one, I've already found one fault in the wiring for the light off the Barretter. And then I was checking out the sound. It just doesn't sound right at all, and the tone control seems pretty ineffective. I just couldn't work it out. It's a very simple circuit. You've got the tone control is just a very simple capacitor with a resistor that just cuts the treble off, so it should work fine. And the value on this, they all use these old Selmer circuits, were all basically the same. It's exactly the same here, and here I can read. It says the volume control's 1 megohm linear, and the tone control's half a megohm linear. So I thought, well, why doesn't it work properly? And the sound is sort of kind of distorted. It's alright low volume, but high volume, it sounds it's not bright at all, and the tone control doesn't seem to do anything at all. A little bit, but it's... Anyway, I tried to take this plate off and have a look at the actual components. I just couldn't work it out until I eventually decided to check the this, see if it's there's something wrong with the track. So let's turn it to full, and It's only showing 50k, so I thought that's weird. And it's only got a capacitor there, so I thought maybe the capacitor's leaking or something. Soldered the capacitor, 51 kiloohms. So this potentiometer has been incorrectly manufactured, marked up. So no wonder the sound is poor, because we've now got, instead of a 500k, you've got a permanent 50k load on this valve, which is obviously in parallel with 100k, which is just pulling the gain down. That resistor's not there. That's one that I was going to put in just to cut the gain a bit, because I think it needs a, if you turn this up full, it should really have a bit of resistance in series with that valve. I've got a 500k linear pot. We'll swap it over, and then we'll see what it sounds like with the correct pot in it. Change the pot, put the capacitor back on. I've also put a small feed forward capacitor, which gives you a little more treble bite at low volume, which I like. It's easily taken off if you don't want it. That's control panel has got to go back, screw back inside. That's why I've got it laid down like this. You have to get 4 screws on the side. It sounds like it's supposed to sound now. All the controls work. The tone control works now. That's the treble. Turn it down. That's the treble off. It's got a good range now of a tone. And the volume control goes up. You get a lot of overdrive, so you don't need it up full. And a bit more a bass. That's working fine. Take some of the treble off. And you can turn the volume down on the guitar a bit. Treble up. Turn the volume up on the guitar. Plenty of treble now. Turn the treble off a bit. Okay, that's what it's supposed to sound like. That's what the other one I made, service, sounded like. This one sounded rubbish when it came. It had 2 manufacturing faults. One, it was a wiring fault. And the main one was that the wrong value of the pot for the tone control, which was loading up the first stage, causing all sorts of problems. With the first stage, it couldn't get any gain, and it was distorting horribly. So I don't know if someone's had this amp for 50, 60, 70 years and just put up with the poor sound that it had, but now it's just fine. And it's got loads of volume if you've got weak pickups. So there you go. Just a quick word about these two inputs, the high impedance and the low impedance. The low impedance one is isolated from the mains. If you didn't have an isolating transformer, and to be safe, but you can't plug a guitar, it's a low impedance, it just sounds hideous, but you can use virtually any foot pedal which have low impedance buffered outputs. And for instance, this is just a graphic equalizer. I turn it off, and this input's pretty sensitive, so you'd have the volume down reasonably low, and the treble and the tone controls, that's the volume, goes pretty loud, and the tone control cuts the treble off as well. Turn all the treble off. Treble pickup on the guitar or slightly off. So there you go, it should have a cover for safety reasons. Now one more thing about these amps, these valves are very microphonic. They pick up vibrations quite easily. Even though this one's on a rubber mount, they will make a noise if this thing vibrates, so you might want to put it on a, if it's on a carpeted floor or something, it would be better than on a hard surface. So, and the light works here now as well. So that's that amp done. Let's just turn it round for you.